Question 10, a calculus question which includes differentiation and integration. Figure 3 shows a sketch of the curve C with equation y equal 2x plus 64 over x squared minus 3. Point P is a stationary point on the curve. Show using calculus that the x-coordinate of P is 4. To find a stationary point or a turning point, we do dy by dx equals to 0, because dy by dx is the gradient, and the gradient of the stationary point is equal to 0. Alright, this is a function. Let's rewrite it. Y equal 2x plus 64x power of negative 2. I moved the x power positive 2 upwards, minus 3. Then let's differentiate. Dy by dx is equal to 2 minus 128, because negative 2 times 64 is negative 128. X power, subtract 1 from the power, it will be negative 3. Dy by dx equals to 0. Move the 128 to the right side to be positive 128 x power of negative 3, or over x power of 3 equals to 2. Move the x power of 3, cross multiplication, move the x power of 3 to the right hand side and the 2 by division. It would give x power of 3 equal 64 cubic root 64. So x is 4. This is for part A. Done. Proved that x is equal to 4. Part B, the point Q lies on C. Point Q lies on C. Its x coordinate is 2. Px coordinate is 4. Alright. The line segments MQ and MP are parallel to the x-axis. Region R, shown shaded in figure 3, is bounded by C, the y-axis, and the line segments. Use algebraic integration to find the exact area of R. In order to find the exact area of R, we will do as follow. We will get the area of this rectangle. So we need to know the y coordinate of Q and P, and this distance is 2 for sure, length times width. And to find this area, we will do integration from 2 to 4. Integration from 2 to 4 minus this rectangle, or we can minus the line after we get the y coordinate of the line. So let's first find the y coordinate of P and Q. To find the y coordinate of Q, we will substitute in the function, which is 2x. Qx coordinate is 2, so 2 times 2 plus 64 over 2 squared minus 3. 2 times 2 is 4. 4 plus 64 over 2 squared, which is 64 over 4, which is 16 by the way, minus 3, so it is 17. This is YQ. YP. This is YQ, or you can say M. This is M. YP, which is N. 2 times 4 plus 64 over 4 squared, which is 16, minus 3 equal, this is over 4 squared, which is 16, and 2 times 4 is 8. This is 9. 9 is N. So this part, let's name it 1, is 2 times this distance, 17, and 9, which is 8. So 2 times 8. Area 1 equal 2 times 8, which is 16. Now area 2 is integration y, integration the curve, integration 2x plus 64x power of negative 2 minus 3 from 2 to 4, right? Then we may subtract the area of this rectangle, which is 2 times 9, or in the integration I may subtract 9, which is the equation of this line. This line is y equal 9, right? So I can subtract the equation of the line, which is y equal 9, from the curve. Either ways are true. This is first approach, and this is second approach. All right, so this is the function integration from 2 to 4. Integration 2x is x squared, add the power and divide by the new power. Add the power, so it would be x power of negative 1, divide by the new power, so it is negative 64 minus 3x from 2 to 4. As you can see, it gives 22. This 22 is the whole area of this, the whole area. If I only want the area of 2, the shaded area of 2, I will need to subtract the area of this rectangle. So how much is the area of this rectangle? Base times height. The base is 2. The distance from 2 to 4 is 2. 2 times the height, which is 9. 2 times 9 is 18. So the area of part 2 is 22 minus 18, which is 4. And by then the area of the whole shaded region R is equal to 4 plus 16. 4 plus 16, 1 plus 2, or 16 plus 4, which is 20. This is the first approach. Second approach is that I would subtract the line y equal 9 from the curve from the beginning and then integrate. And by so I will get direct the area of 2. Subtract 9, which will be negative 12 minus 12, and definitely the integration of this should give 4, direct. Let's see. Integration will also be x squared minus 64x power of negative 1, but minus 12x. Okay, plug in the calculator. This negative 3 will be 12, this negative 3 will be 12, and as you see, it is 4. It should give 4, definitely 4. And also the area of R will be the 16 plus 4, which is area 1 plus area 2. This is for June 2025 variant A exam. It was pretty hard, but I hope you understood all the questions, and see you in another exam. Goodbye.